My name is Nelly Lovchikova, and I am a solutions architect here at AWS. Today's topic is 2 cool features of Amazon Elastic Container Service. You can have serverless Fargate containers with Windows and AWS Fargate powered by Graviton-2. Don't worry if you didn't get what I just said. I'm going to explain what is it and why you should stick around and watch. But really pay attention if you have some older Windows workloads or you care about our planet. Full disclosure, it is a 30-minute session and I can talk about containers and developer experience for like 30 months. But today we focus on those specific things. Let's get started. There's our agenda. We're going to briefly talk about containers and how they benefit you as a developer. Then we quickly dive into Amazon ECS and AWS Fargate. Then move right on why should you be excited about serverless Windows containers and how they work. As part of that, I'm going to demonstrate how I deployed ASP.NET applications serverlessly, and I recommend to stick around because I have some cute photos of my dogs there. And in the last part, we're going to explore how Graviton-powered Fargate can help you and the environment. And also, there is a demo of migration from x86-64 architecture to ARM. Now, the main point of containerization is to overcome this complexity of software delivery. While the idea of containers was around for about 50 years now, the actual usage exploded after 2013 with the Docker maturity. You see this quote, and honestly, I experienced that many times, and I'm sure you did too. Works on my machine, doesn't work in production. Why that? You see, our software isn't really just a code. We usually pack a bunch of dependencies, configurations, and they all rely on a runtime engine. So many moving parts. In addition, since coding and ops are quite different disciplines, often people who deploy and monitor are different from people who code. And we all humans, meaning our communication, is not very efficient. Different environments adding extra complexity. Variety of operating system versions, installed packages, systems crammed together into the same box. I just say it is hard. From my experience, coding is a breeze. Deployment, nightmare. But there is a solution. When you pack all your moving parts into a shipping container, you no longer rely on a human interaction to ensure your system is working. You can do it yourself. Now, when you need to debug, you can do it locally because your environment is exactly the same as production. Of course, then you cannot imagine yourself as a surgeon operating on a beating heart, but I prefer to be safe than sorry, at least in this case. Now, when we understood containers' benefits, let's think bigger. I hope now you want more than just one container. That means we need the way to orchestrate those. Orchestration service like Amazon ECS is taking care of allocating resources, configuration, networking, and monitoring. Let's look at those ECS architecture. It all starts with a cluster. It provides nice grouping so you'll logically link your containers. For example, all services related to customer success are going to be living together. You also use a cluster as an IAM permission boundary. For example, users who belong to a customer success team have privileged access to customer success cluster and no access to user management cluster. Then there is a task. A task is an instantiation of a task definition that is running on a container instance or AWS Fargate. A task definition is the blueprint of your task. specify the name of your task, revisions, container definitions, and volume information. Task definition also has information about where the image stored, and you're free to store your images wherever you need. Here in AWS, we have Amazon Elastic Container Registry, and it provides really nice integration with ECS. Later in the demo, I'm going to assign a task execution role to a task definition, and this role is going to have policies allowing ECS to fetch my image from ECR. And finally, we have services. An Amazon ECS service enables you to run and maintain a specified number of instances of a task definition simultaneously in an Amazon ECS cluster. If any of your tasks should fail or stop for any reasons, the Amazon ECS service scheduler launches another instance of your task definition to replace it in order to maintain the desired number of tasks in the service. Fargate is a serverless compute engine for ECS. Serverless doesn't mean there is no server, but rather than who is managed it. Because even if there is a server behind, but you don't manage it, it becomes an utility. And you don't care that much. So AWS manages the services for you, meaning patching, testing, provisioning, scaling, and you obviously pay as you go. You see how shared responsibility shifted toward more work from AWS and less work from you. If you run your containers on EC2, you are responsible for keeping container runtime patched and healthy. You need to invest into storage, logging, install monitoring plugins, and again, keep it all updated. And it is relatively simple on Linux, but on Windows, maybe not that trivial. And also, you not only install and update, you'll also need to test it and ensure it works all the time. And finally, operation system. For example, if it's Windows, then you need to make sure you have appropriate license and so on. But if you decide you want to use Fargate, please forget all those technicalities I was talking about for the last minute or so. All you do is to build your application according with your business needs. Select appropriate CPU and memory, and here we go, ready for production. Normally, when I'm talking technology, I say, when you have a hammer, everything looks like a nail. Use technology wisely and only where it's appropriate. That is not the case with containers. If you have an application that requires some kind of compute that is not going to run on your local PC, you have to ship it in container, period. Until recently, that statement had an addition. Unless you're using Windows operating system or ARM processor architecture, because those technologies traditionally aren't supported. But no more of that. Let's see what we have for you. Recently, AWS introduced Fargate with Windows Server. Before we begin, I would like to clarify one important misunderstanding. You see, when people talk about legacy software, it usually has some negative flavor and implies this software is somewhat not important or something is wrong with that. But if you rebrand it to revenue-generating software, because it is what it is, you'll get completely different picture. So please use the right term. Why you should care about Windows serverless containers? First of all, C# is a very popular language according with the Stack Overflow Developer Survey of 2021. And while now you can deploy your modern .NET applications to Linux environment, there is still a lot of revenue-generating software around, built on older .NET frameworks that require Windows and often IIS to be present. Just to indicate the importance of that, having a serverless containers with Windows is in our 5 top requests from customers. So here we are delivering for you. Just a remark, because we manage your server and you won't have ability to interact with it, so no RDP, SSH, PowerShell. It is serverless and it is all about your application. Few interesting facts about Fargate with Windows Server. AWS Fargate based on Windows Server 2019. We have both full and core, and we are looking to add more versions. Second, Fargate is designed to avoid noisy neighbor problem through nice kernel isolation without Hyper-V. Behind each Fargate task, there is an EC2 instance. And also a new updated AMI and container-based image following Patching Tuesday. In this demo, I'm going to demonstrate how I deploy my .NET Framework application into AWS Fargate. We're going to look into console and see what kind of monitoring is available. And also I'm going to quickly show you my infrastructure as a code based on Cloud Development Kit, because we are developers and like to see some code. Let me introduce you Doc Portal. It has been built exclusively for our family because we have 2 puppers, Kelpie Dusa and the border collie cross Kelpie Klusha. So we need some place where we can manage them and enjoy their pictures. Here is my ASP.NET application built on .NET Framework, so it requires IIS to be able to run. As you can see, I already containerized it by adding Docker file. For the simplicity, it copies file from my release folder on a local machine. Very important part, I used Windows Server Core 2019. This version is currently supported by AWS Fargate. Now let's see how to go from a Docker file to a fully deployed application. There are a few steps, and I'm going to walk you through. First, I'm going to build a container image, give it a name, IS site. During build, it is going to download base image. It is around 9 gigabytes. Don't worry, you don't have to download it every time, just new version. This image is very important. You can run it, you can share it. And first, let's run it locally to make sure everything is working. I run this image by using docker run command. I'm going to give it a name so I can identify this running container later. Also, I need to set up a port mapping. The .NET application set to respond to port 80, and I'm going to remap it to port 8000. Let me run docker ps command that gives me a current situation with my local containers. And here's my container, up and running. As you can see, it runs locally on Windows container without any problem. Since everything looks good on my local machine, let's bring it out newly built image to the cloud. You can use any repository, but I'm going to use Amazon Elastic Container Registry, ECR, because it is all integrated together, and I can control permissions using my standard IAM policies. Let's see what we have. The Docker images command produces a list of local images, and I need an ID for the image I intended to push. The image needed to be tagged with the docker tag command. The tag consists of repository ID and ECR and version. If you run your docker image command again, you'll find your newly tagged image in a list. Once tagged, then it can be pushed again using standard Docker API. And it's going to upload all those 9 gigs, which is a base Windows image, plus my application, its dependencies, and configuration to the cloud. So in real life, I won't do it locally, so I don't have to download and upload so much data. I would build a cloud CI/CD pipeline for that. Right now, I'm at ECR repository, and here you can see our image. Let's create a cluster. As you may recall, cluster allows you to group your containers. For Fargate, we need to select networking only. as Fargate is going to take care of everything else. I'm going to give it a name, and here we go. Cluster creation is really fast. Now let's create a task definition. So you select Fargate, give it a name, and here I'm going to select a task execution role. That role is very important. First of all, it needs to give a permission to fetch an image from repository and do other administrative tasks, like logging. Also, if your container needs to make a request to other AWS services, this is the place to give it the permissions. So here is why we're here. Select operating system. And it's very important to use the same operating system and the same version as the base image of your custom image. Then you can choose task memory and CPU. This is not a whole box parameter. Those resources are going to be dedicated to your application, and you are paying for those. So we have a .NET application. I'm going to select 2 GB of memory and 1 virtual CPU. Then we're going to add a container definition, give it a name, and specify an image from the repository, including tag. Set the port mapping. You remember our application exposed port 80. And there my task definition is fully defined, and now I can create a service. So now let's jump into my cluster and create a new service. And again, I have to select the right operating system. But in this time, the system doesn't allow me to select the wrong one. I need to set a service name and the number of tasks. Number of EC2 instances are going to be provisioned for the service. I'm going to add a tag, and here we go. Setting networking connectivity and select pre-created load balancer. And I already created my listeners, so I just have to select them from the list. Windows tasks takes longer to provision than Linux just because it takes some time to move and have an image and start a container. Pay attention to highlighted area. Right now, Fargate trying to achieve number of desired services. And here we go. Now we have running count 1 and the status is running. Here you can see my girls have public IP now. Let's see what kind of metrics are available out of the box. I put a little load there, and you can see the whole cluster metrics. And also you can see virtual CPU and memory utilization per service. Let me show you something interesting. We are developers and we like to see some code. What if I tell you that almost everything I just demonstrated can be just one page in a source control? Let me introduce you Cloud Development Kit. It is a way to model your infrastructure, so you don't define how it is going to be provisioned. You say, I want a cluster, and it is going to be provisioned for you. Multiple languages supported, like JavaScript, TypeScript, Python, Java, Go, and because we're here talking C# today, I thought I'm just going to use it. So here you see me modeling cluster, then define a task definition. Most of the configuration is by default, and I only need to set changes. Then I added a container definition, exactly the same way we just added in the console. Just give it a name, port mapping, and an image location. And the last I provisioned the service. After your code is done, you can deploy it using cdk deploy command, and it is going to be taken care of. I really prefer this way, but I'm not opposed to use UI or CLI, so please enjoy any of these tools. With Windows, you have two options. First, you can go on demand and pay as you go. But if you have a long-running and stable application and you are happy to commit to 1 or 3 years, I would check our savings plans. With those, you can slash your bill in half for compute or part of it. And we have the great tooling that can help you to figure out how much you need to commit to. Recently, we introduced AWS Fargate powered by Graviton-2 processor, which is ARM. These are just normal Linux instances with all normal features. Logging, monitoring, tracing, Amazon EFS is supported as well. The same old Linux, just powered by ARM processor. Why would you want it? First of all, if your local development machine is powered by ARM processor, obviously you want the same processor architecture in production. For example, Apple 2021 and M1 Mac. Second, you want ARM because you care about environment. Graviton-2 is 3.5x more energy efficient than standard x64 instances. And here's the important part. If you want to save money because your workload are going to be up to 40% more cost effective than equivalent x86 or x64 instances, let me show how to migrate. Here I have a demo for you, and this is real life thing that happened with me. I was happily developing an app on my old Mac Pro, but its life cycle came to the end and I was sent a brand new shiny Mac powered by Apple's M1 ARM processing unit. Now I have a dilemma. What would I do with my production? Am I okay with having different processor architecture in different environment? No, of course not. I want to sleep peacefully after deployment. So here I'm going to demonstrate how I migrated my app to AWS Fargate powered by Graviton-2. To be honest, this demo is going to be very short because migration is easy. Here you see my CDK code for Linux using CPU architecture specified as x86-64. Let me show how this task definition looks like. Here you see in full configuration it is exactly that. Now let's get back to my code and change CPU architecture to ARM. And when I deploy the snippet using CDK deploy command, it's going to create a new revision of my task definition with ARM processor. The old definition become inactive, and now AWS Fargate started to provision resources for this one. And that's it. With Fargate powered by Graviton-2, you may enjoy exactly the same benefits as 64X processor. Pay as you go, on-demand price offering. Save up to 52% with long-term commitment, or if your application can handle some potential interruption, you can save up to 70% by introducing unused capacity to your fleet. Now, what I want you to do is, if you have a revenue-generating Windows software living on-prem and in any kind of virtual environment, I encourage you to go and try to migrate it into container. Give it a go. Let's see how much your life is going to be improved. No more patching, outages, easy monitoring, consistent environment. You want it, you just didn't know. For those who are in a Linux world, if you develop an ARM processor-powered machine, and even if you're not, you still should care about our planet and deploy our workloads responsibly. Imagine the world power consumption dropped significantly if everybody uses less power without losing performance. Maybe we can buy ourselves time to figure this climate disaster out. You can make a difference. So you want to make a difference but don't know how. Well, we can help. There is a skilled builder program, which is pretty cool and also free. I personally want you to go and learn. So next time I see you in a meeting, you can properly attack me with all these complicated questions, and we have a meaningful conversation. And also, did you know that AWS certification is not just a cool badge? It's also a community that brings together AWS certified practitioners and builders, and I'm sure you want to be part of it. Now scan these QR codes and find out what you can achieve. It was Nelly Lovchikova with you, talking about containers. You can find me on Twitter. I occasionally tweet, but I'm always happy to connect. Thank you.